So here we are. This is the 1928 DRA-2 refrigerator. I talked about this in the other video where we had to do a rebuild on this thing. Fellow that owns it did a lot of refurbishing on it. Looks very nice for being 90 years old. And it was in pretty good shape. It ran, except that the stator was in the motor there was shorting out to ground and was overloading it and causing it to shut down. So he made the choice that we would tear this thing to bits and pieces and pull the stator out, send it off to California, have it rewound for an obscene amount of money. And we reassembled the whole thing, put it back together, and we're really quite nervous about the whole thing. A lot of time went into this device, into this machine. So pulled it down to 41 micron with my vacuum pump, read at the pump there. After several evacuations and purges, and got it down to 41 with my old vacuum pump that I've had for years. Charged it up here with R124. We're at a little over 4.5 pounds, I think 4.7 pounds. The original charge for this thing called for 5 pounds of sulfur dioxide. There's the original tag. And you can't see it, but it says down here 5 pounds sulfur dioxide. So sulfur dioxide is not an easy refrigerant to get anymore. It's rather expensive, and if you've ever smelled it, it's a horrendous substance. But it's a great refrigerant. But regardless, we ended up choosing a modern refrigerant and a modern alkyl benzene oil for this machine here. So this is the control, all electromechanical. This starts the machine. This regulates the temperature of the cabinet. This is the 1928 equivalent of a control board. Very robust, very neat. A lot of springs and a lot of lever actions and things going on there. We have a little start relay up here, which engages or disengages this contact up here, which will cause the start winding to be engaged, and then once I think the current drops enough, this coil releases because of a spring action that pulls it away, and then we just have the run winding. We have a bellows down here. This is an early form of a thermostat. These are pretty reliable. I don't know how easy it would be to try to locate something like this other than a used item, but that's connected to that piece of about 1/4-inch copper tubing, which is the equivalent of like a capillary tube you'd see on a modern thermostat. So that bellows can expand and contract depending on the temperature inside with the refrigerant that's in that tube there. And it can act against this plate, which has a spring on it, and by adjusting this little roller here, we can adjust the amount of expansion or contraction that would cause this to trip the unit on or off, depending on the temperature inside. This down here is, I think, some sort of a relay. I'm not exactly sure what the purpose of that there is, but we'll make sure that stays in there. We have an overload over here. There's a bimetallic strip that, when heated by that piece of serpentine wire that I believe the run winding is powered through, if there's too much current, that'll heat up, cause the bimetallic strip to deflect, and will trip off the end of this start button right here and shut the unit down. We have an off button up here that serves the same purpose. It'll trip it. And you can see all the wiring on the back. He did a nice job polishing every screw, everything. So we're looking good. We're up and running. We have about 4.7 pounds out of the 5 of sulfur dioxide. I don't know where I'm going to end up at, but we're just figuring out as we go here. I did do one modification here on the condenser. At the bottom of the condenser, we have a liquid line filter that was adapted in with some copper lines into the high side float, which is there to try to protect the orifice from any debris that might plug it up, because that can cause you some issues. There is a float in there that when enough liquid is dropped in there, it causes the float to rise and admit liquid into the evaporator in the cabinet. I suppose ideally, and when this thing is up and running smoothly, that's not going to oscillate much. It's just going to kind of rise to a point where the liquid can gradually fall through that orifice and then drop in pressure. And then there's our service valve, which is hooked up right now to our gauges, and we have about 74 psi, which corresponds to it's like 105 degrees Fahrenheit. So the top of the dome is nice and warm. It's almost hot, but you can still touch it. I'm pretty happy with that right now, but I'm not sure if the evaporator has enough, if we have enough refrigerant in it, so I'm probably going to be adding a little more. The low side is not hooked up right now. This unit never had a low side port, except from factory, which was sealed off and crimped, much like a modern refrigerator. I did take the time to add a simple Schrader port to the back of the evaporator, and I charged it with about 2 pounds of liquid with my tank upside down. Once it started to slow down quite a bit, I went ahead and flipped it right side up and switched over my gauges and charged as a vapor. So there's the evaporator there. We're getting nice and frosty here on the bottom. It's cool. There's some condensation near the top, but it's really not very frosty towards the top. The inside is quite frosty up towards the top there. So I'm feeling I'm going to have to end up putting a little bit more. Cabinet temperature is about 49 according to that, and we got a little one back in the back here, which is registering about 23 or so. The low side was running at about 4 psi. 0 is about 11 degrees Fahrenheit. I think 4 is probably, up there around, let's say, 18 to 20 degrees Fahrenheit. I have to check the chart. So pretty happy right now. Thermostat is not cut out yet. I don't expect it to for a little bit. Probably going to wait until it does, see what temperature it gets to, and check that evaporator. And I'm going to hook up the low side again and see what it's running at. In all likeliness, I'm probably going to add up to 5 pounds, stop there, and then do this process over again. If you want to see this thing in infrared, I'm going to go ahead and do a video just now, and you can see what business is going on there.